Okay, hi everyone. This is Team 6. We have implemented our Steam implementation for Marta Transport System. We are 4 members in the team. We will introduce ourselves as we go forward. Uh, so this is our demo presentation for our implementation. So this is our slide. Let me just make it in the slide mode. So this is our presentation flow for today. We will start with our introduction of all the team members. Then we will go to the deliverables. We'll match what are the deliverables required for this implementation. And then the UML diagrams will be followed after, where we will come up with the class diagram, how we have implemented the class diagram, the sequence diagram, the use case diagram, and the deployment architecture diagram. Then we will do a demo of our implementation, and then a code walkthrough, and then followed by the unit test cases. So I'll introduce I'll hand it over to my team member, Bill, to introduce himself.
My name is Bill Adegbero.
Yeah, then this is Neelmani Chaudhary.
Hi. Hi, this is Komal Desai.
Hi, this is Jitendra Kumar.
Yeah, thank you, Jitendra. So I will hand it over to Komal now, so she can go over what we have. Komal, over to you.
Yes. Yeah, so as part of the deliverable for this project, we are going to deliver the 4 deliverables, which are VirtualBox OVA file, and we have a link to the file. We are delivering a source file, which is in the our box folder in the Georgia Tech folder. We have a design document PDF, which covers all our UML diagrams, and we will have a link to our video recording on the following slide. Next slide. Next slide, please.
Yeah, I've actually switched, Komal.
Part of the UML.
Go ahead.
Yeah, thank you. As part of the UML diagrams, we have decided to cover 2 structural diagrams. Structural diagram depicts the structure of the system, and we have done 2 diagrams. One is the class diagram, and another one is the deployment diagram. For behavioral diagram, we have also developed 2 diagrams, sequence diagram and use case diagram. As shown in this class diagram, it shows the relation amongst the various data objects such as bus, stop, etc., and service level objects, Marta system helper, etc., and their interaction. Next slide.
Sure.
Can you go to the sequence diagram covers all the various workflows. We have chosen to show the sequence diagram as one workflow, and each workflow is been color coded to differentiate different workflows. So PDF.
Yeah, let me just switch over to the PDF file. Give me 1 minute. So this is our design document, which is another submission. And then this is our PDF where we have the sequence diagram. So let me just maximize this, Komal. Give me a minute.
Sure.
Okay, I think it's already maximum.
Okay, so as you can see, the very first one iterates over how the initialized system works, followed by we have a move bus related workflow, and they are all color coded in a way so that you can differentiate between the different workflows separately. We may want to now look into the UML deployment model, which Neelmani will cover.
Yeah, so thank you very much, Komal. Yeah, so within our slides, we were at this class diagram and the sequence diagram. Then there's a use case diagram. So we have provided in the slide the use cases which we have. So we typically have the initialize bus system, which initializes the application, sets the files for input. Then we have an update bus route use case, update bus use case, and we will see how, like during our demo, we will have more understanding to it, how we've implemented it. Like then passenger management can be updated. We also have a system efficiency use case, which the system efficiency is calculated by the system and refreshed on screen. And then we have the system efficiency coefficients or the cost factors. Coming to the deployment diagram, the way it is designed is that we have installed, we are using Java Standard Edition 1.8. On top of it, we have a jar file, which essentially consists of 5 main packages. We have the data components, all the DTOs, the data type objects are under the package named like this. Then we have a UI component where we are using Swing as a Java X Swing and the JFrame capabilities for the UI component. Then we have an exception handler, which is a common Marta system exception. This is our custom exception handler component under the package with a named as exception. We have unit test cases also, which are under the package named here. And then we have a singleton pattern like on the package on the service component, which basically has a singleton of the implementation. Okay, so now I will switch to the demo UI. Before coming to the screenshots, I would go to the Oracle VM and then run the UI our application using the jar file that we have just developed with our team. So I am currently in the directory for our team 6. And yeah, Komal, you want to add something?
Yeah, I could not see your screen, the terminal window.
It's coming. So on this one, we have the working system team6.jar file, which is our submission, which is like the compiled jar file. So I will run it as java-jar working system.jar. This will start our implementation, our instance of our app implementation. So at the top panel, we have the messages of system efficiency being calculated, the constants for speed, capacity, passengers waiting, the bus cost, the combined. We also have a system status panel at the top, which shows like the current messages, whether these are like positive or negative messages that the system produces. Then we have a middle frame, which will be updated once we initialize the system. And at the bottom, we have a frame for 6 buttons, actually 7 buttons, where the initialize update system is the starting point of our application. So I'll click this button. This pops up a window where it asks us to choose 2 files. One is the setup file, which is the input txt template files that we are provided. I can choose any of these files here. For understanding, I'll choose a simpler file first. Actually, I want to show that the negative part. So if I choose a bad file name, which does not exist on the system, and then try to click confirm, the system will give an exception or a message at the top saying that the file is not present, no such file or directory present. So it requires a correct file to be chosen. I will select a file, take a simpler file, then choose another setup file. Now we have deliberately disabled the filters, so it will only look for CSV files, which is the expected behavior. So it's a little easier for the user to handle. Then we have a confirm button. So as I click confirm, the system will initialize and it will show on the frame the 3 files, or like depending upon the input files, it will show the messages. Just to understand this here, like we have the bus icon, the stop icon, and then we have the names. So the naming convention we've also presented in our PPT or our deck, but I will just try to explain how it means or what it means. So bus number, so for example, the one that I'm pointing to at right now is bus number 69, which is at stop number 5. Arrival time is 0. Passenger capacity, current passenger count is 0. Capacity of this bus is 10. It's on route number 56, and the speed or velocity, I mean denoted by V, is 60. So right, so when I click move next bus, the system will take the latest event and then move the next bus. So as I click the button here at the top, the move bus executed successfully for bus number 69. So so it shows up. We can also take a bigger file or so as to show the complexity. So our system is able to take a larger file as well, and I can choose to update the distribution file as well, the passenger distribution, and click confirm. The system will then get updated with the latest file that was uploaded. And we have like a lot of so we have around 17 stops on this using this file. So if the move next bus still keeps on, and then at the top the bus number 63 or whatever bus number keeps moving. We also have implemented the rewind and replay bus feature, where up to 3 levels the system can go back. So as you see, bus number 61, I click one more time, bus move. So now bus number 62 has moved. I click one more time, now 64 has moved. Now if I click on rewind, so it will go and say 64 has moved back, then 62, and then now again if I click one more time, it should be 61. When I click it, as you see here on the message, it is the bus number 61. If I click one more time, which is now more than 3, the system will give a message that it can only be done to 3 consecutive times until the event stack is empty. So I would now like to introduce or call Jitendra. So he will explain like how we have implemented the other buttons. Jitendra.
Yeah, thanks, Neil. So we already have seen like initialization, move, and rewind. So there are things that we need to cover is like we have to set the bus parameters and we have to set the system coefficients. So like we have to calculate system efficiency, and for that we need to set some parameters like K speed, K capacity, and K weightings, and K combined, and K bus cost. So for that we have a button in the control panel. When we click, so we can see this kind of input, and we can enter the values, the new value that we can. So default has been set at 1.0. So we can choose one, we can fill all. So depending on whichever is set, that value will be taken and that will be updated immediately, and the status will be updated, which value has been set and which are the not filled value. If there are something invalid value entered there, that will be shown in the status bar. Then we have like bus parameters like speed, route, and then the capacity. So we can open that and we can choose the bus ID and we can fill the corresponding the new speed or the route and the corresponding stops and the capacity. So when we fill that, so it will take that input and then it will store it and it will wait for the bus to execute next time, and at that time it will apply those values. So that will be taken when the bus reaches the next stop, and then it will apply the new speed and the new capacity, and then it will move after that to the next new stop that we have selected. So any error messages that we can see in the status message, or the success case also we can see the status message. And on every move we are calculating the system efficiency, so that can be updated, and we can see that on the status panel, system efficiency, how the values have changed.
Right. Yeah. So this is the high level of like our implementation. Actually,
Yes.
we will go into the lower level implementation. So although right now I was showing it on the virtual VM box. So this is our now I will use Eclipse. We have used Eclipse and IntelliJ, and we've used Git, the Georgia Tech Git for our version control, so that we can collaborate with each other. So here we have created 5 packages, mainly as we saw in the deployment architecture diagram. So we have the UI package, which we will come to. Then we have the test package where all the unit test cases are put in. And we have the services package where all the implementation logic is supported. Then we have an exception package where our custom exception handler is there. And then we have the DTO where all the bus route stops and the bus system, which is our biggest object, the bus system object, are there. We also have an interface for all the constants which are inside this. So if I double click, so all our constants are here. So our starting point is the main.java program where the application starts. And then Jitendra, if you would like to just cover the UI piece, the UI piece of the code.
Right. So yes. So thanks. So when we start the program, so from the main, it will call. There is a we are creating a frame. So the UI will start. So that's basically a J frame. And in that frame, we have like 3 panels we have created. The first panel is actually for the bus system display. So it will display all the coefficients and the efficiency and the status message to be given to user. The next panel actually is where we can show the buses and the stops and how they are relative to each other. And we will give the status of the bus and the stops. The third panel is where actually we are giving control to the user. So a user can actually set, like he can choose what case to initialize, and he can change the bus parameters, and he can set the system coefficients, and he can refresh the efficiency, and he can do move and rewind bus. So these 3 panels actually we have created. That's J panel. And for each button, we have a like handler for that. So whenever user could try to control that button, so that handler will be called, and from there actually the service will be called. And the top status panel actually it is a J level and a J text field. So by the J level we can identify which parameter actually we are trying to display, and the text field actually is the value that user has set. So and the status text field actually will give a string for the system status, or you want to give a feedback to the user.
Correct. So every time, as Jitendra mentioned, like we have implemented like the different button handlers. So for example, bus capacity change, bus route change, there are individual button handlers which call the bus system interface, and then the interface has these use case or methods which are implemented in the system IMPL, which is the actual implementation behind which supports the interface of MARTA system. We also have a helper class which does like lower level implementation logic, and then it has some private methods also that sets up the implementation and like supports the implementation. And then we are anyhow submitting all the source code so that you should be able to take a closer look at it. I think in the interest of time, we should go back to our slides. So we've added some screenshots in the PPT, and then we have the naming convention here. As we saw in the demo, the UI, the move bus, rewind bus, change route, some error conditions, how we have handled it. We've seen just the code walkthrough, and then this is our site where we have like the URL for web version control. I would now introduce, like to call Bill. He will help us with the understanding of unit testing.
We did some unit testing on our service classes and also on the utility classes. In the service classes, go back to the last screen, please. We on the unit classes, we tested the initialize test, the update system parameters, the move bus, and the rewind bus services. And we also have a test suite that combines all these tests together to give us, and the next screen shows us on the outcome when we run each of our unit, when we run the unit test or when we run the test suite.
Yeah, and all the tests are just packaged under another package here. As Bill was mentioning, we have an all test suite where we have called all the classes. Yeah. Komal or anybody else, you want to add anything else before we end this demo?
No, it's great.
Yeah, I think we are done.
Thank you very much.